again. I'm Mark Story. We're at Bellevue College and you're in Symbolic Logic. For this short video, we're going to take a look at conditional proof. Conditional proof is a technique that usually makes getting conditionals easier. So if your conclusion of an argument's a conditional, a horseshoe statement, you probably want to use conditional proof. It'll probably make the proof shorter and easier. So let's take a look at an example. Here we have two premises and the conclusion is a conditional. That's the first thing I'm noticing. I look at the conclusion, I see it's a conditional, and I think, let's use conditional proof. If it wasn't a conditional, I might use indirect proof, a technique we'll look at later. Well, let's look at conditional proof here. The way conditional proof works is you indent to the right and assume the antecedent of your goal. Just do this almost mindlessly. That's going to work. So assume the antecedent of your goal, and you write A, C, P, assumption conditional proof. Now, I don't know that A is true. I'm pulling this out of thin air. I'm just saying, what would happen if A was true? If A is true, I really want that to be the case. So I'm now looking for B dot G. And it'll probably be easier with this assumption than it would be otherwise. We can see there's some things we can do. The next step might be a modus ponens with 1, 3. That gives me a B. That's not what I'm looking for, so I continue on. I could also do another modus ponens. That gives me a G. That would be lines 2, 3, modus ponens. And remember, I assume the antecedent, I look for the consequent. Chant it like a mantra. Assume the antecedent, try to find the consequent. Well, I can do conjunction now to get exactly that, B dot G. That would be 4, 5, conjunction. So I assume this. So it looks like if A is true, B dot G is guaranteed. What conditional proof lets me do then is I pull out to the left and say exactly that. If A is true, then B dot G is true. And I write 3-6 CP, conditional proof. Notice it's a dash here because I'm appealing this entire sequence. And the way this works is we draw a line here, locking off those lines for any future use. Well, we're done. We don't need those lines. But in other proofs, you might need to go back and try to use something. But I can't use these because all conditional proof lets me say is if A is true, then B dot G would be, which is what I get right there. And as soon as I get my conclusion, we're done. So here's the things to look for conditional proof. Make sure whenever you assume, you indent to the right. Every time you do CP, you indent back to the left. You'll get underneath the original column. That should be a dash because you're appealing to this entire sequence, 3 through 6. And don't forget to draw this vertical line. That locks it off, locks these lines off for future use if you needed to continue using the proof. Try using it. You'll find it makes the proofs a heck of a lot easier.